complex exponential sequences. The complex exponential sequences is of the form x of n equal to e power j omega naught n. Again, using Euler's formula, x of n can be expressed as x of n equal to e power j omega naught n. Same. Okay. Euler's formula here, what? Cos plus j I sin theta, I sin. So for theta we have to add omega naught n plus j sin omega naught n for theta, cos theta, sin theta. Same. Here j I sin theta will come. You know already Euler's formula. Thus x of n is a complex sequence whose real part is cos omega naught n. Okay. This part, real part, that is cos alpha naught n sin alpha naught n is the imaginary part. This is the cos alpha naught n is the real part. X of n is complex sequence. Complex you have seen, no? Complex sequence whose real part and then imaginary part. Sequence. Real part plus imaginary part is coming, that's why sequence. See, due to sequence, cos plus I sine, that is Euler formula. That is the anyway sequence. Periodicity of e power j omega naught n. Periodicity of for which e power j omega naught n. In order for a e power j omega naught n to be periodic with period. Periodic means same, repeat. Sometimes content will be changed, but the period, that time is same, approximately we can say. So periodic e power j omega naught n to be a periodic with the period n is greater than 0 is the, this condition is the period. Sigma naught E must satisfy the following condition. Alpha naught, sorry, the omega naught must satisfy the following. Omega naught divided by 2 by equal to m divided n. M is the positive integer. Here periodicity f e power j omega naught n, in order for e power j omega naught n to be periodic with the period n is greater than 0, omega naught must satisfy the following condition. That is omega naught divided by 2 by equal to m divided by n. M is the positive integer. Thus the sequence e power j omega naught n is not a periodic. It's not a, that is e power j omega naught n is the is not periodic for any value of omega naught. or any value of omega naught, it is not a periodic. It is periodic only condition. What is condition is that for periodic, if omega naught divided by 2 pi is a rational number. 2 pi is the rational number. Omega naught divided by 2 pi is the rational number. Note that this property is quite different from the property that the continuous time signal e power j omega naught t. That is, here this property is entirely different from continuous time signal. While continuous time signal e power j omega naught t, that term is different. Is periodic for any value of omega naught. For any omega naught, this is the periodic. For this omega naught, not periodic. Thus, that's why if omega naught satisfies the periodicity condition in equation 1.54, that's why omega naught satisfy periodic condition. Omega naught not equal to 0, and n and m have no factors. M and n have no factors in common. Then the fundamental period of the sequence, and the fundamental period of sequence is x of n is n not given by x of n naught is given by n naught equal to m of 2 pi divided by omega naught. That is here for periodic 2 by 2 omega naught divided by 2 by m by divided n. M is the positive integer. Here n and m have no factors in common. That the fundamental period of the sequence x of n in equation 1.52 is ny is given by m of 2 pi, that is m equal to this is reciprocal here. Okay, this that we can say for this n, so equal to what happen, so cross multiplication, that's why m here coming here 2 by reciprocal sigma naught. Another very important distinction between the discrete time and the continuous time complex exponential is that signals e power j omega naught t are all distinct values of omega naught, but this is not in the case of for the signals e power j omega naught n. Here, that is another very important distinction between discrete time and continuous time complex exponential. That is, signals e power j omega naught t are all distinct values of w, distinct values of omega naught. But this is not in the case. It is not in same case in discrete time signals. For continuous time it is okay. For discrete time signals e power j omega naught n, here this omega naught n is not mm, not distinct. Here all are distinct for distinct solids. Here it is not a distinct. That's why here omega naught divided by 2 by m power n. So alpha is greater than 1. For figure A, alpha is greater than 1. For figure B, 1 is greater than alpha, alpha is greater than 0. B, 1 is greater than alpha, alpha is greater than 0 for figure B. For C, 0 is greater than alpha, alpha is greater than -1 for C. This is the n direction. Here, that alpha is in between 0 and -1. D, alpha is less than or equal to, less than -1. D, alpha is less than -1. This is for C, this one. Consider the complex exponential sequence with a frequency del naught equal plus 2 by k, where k is an integer. Consider the complex exponential sequence with the frequency omega naught plus 2 by k, where k is the integer. E power j of omega naught plus 2 by k of power n equal to j power e power j omega naught n e power j 2 pi kn e power j omega naught n. Since e power j 2 pi kn equal to 1, from equation 1.56 we see that the complex exponential sequence at a frequency omega naught is the same as that at a frequency del naught plus or minus 2 pi, del naught plus or minus 4 pi, and so on. Therefore, in dealing with this discrete time exponentials, we need only consider an interval length 2 by which to choose. Why not? Usually we will use the interval 0 is less than or equal to sigma naught is less than 2 pi, or the interval minus pi to pi to plus pi, that is minus pi less than minus pi less than or equal to pi naught. Pi naught is less than pi, that is consider the complex exponential sequence with frequency del naught plus 2 by k, where k is an integer. Since e power j 2 by kn equal to 1, this is the complex exponential sequence at the frequency sigma naught is the same as at that at the frequency del naught plus 2 pi, sorry, omega not del omega naught plus or minus 4 pi, and so on. Therefore, in dealing with the discrete time exponentials, we need only consider an interval of length 2 by in which to choose. Omega naught, usually we will see use the interval 0 to 2 pi, that is 0 to omega naught is less than 2 pi, or the interval